Good morning. Today in this video we're going to continue working with the unit of magnetism, working with magnets, but today the topic is going to be a little bit different. Now, for today the topic is electric current produce magnetic field. Now, let's see right here. First, in 1820, Hans Christian, he was doing an experiment and he found that a compass needle would be deflected away when he connect a wire to a battery, and it will return pointing to the north when the battery was disconnected. Now, if you remember from last week, compass, they are always pointing to the north. They are always going to the direction of the north of the earth. Now, what happened? If we have a compass, let me say right here, and it's close to this wire, and we have current going through the wire, the compass that is over going to the north, it will shift, it will move from a direction that it was before pointing to the north, and now it will go to a different direction. Now, when you disconnect the wire from the battery, it will go back again, pointing to the north. And that was something really like weird. I say, what is happening here? After a lot of experiment, he explained that the electric current produce a magnetic field. You need to remember that the only way that the compass they work is because they are pointing to the magnetic north. They work using the magnetic field of Earth. That means they're always pointing to the north since they are going in the same direction of the magnetic field of Earth. That means if they are moving away, it's because it's being produce a magnetic field that is moving these needles. Okay? Now, and that's the important part. Electric current will produce a magnetic field. Now, this is the first experiment that have evidence prove that electricity and magnet field are created. And this is the second point that is really, really important. I mean, this experiment has a lot of importance since it's the first time that we can connect electricity and magnet together in the same topic. Yeah, like together here. Now, next part. If we can see right here, we have here a wire and we have the current that is going through the wire. Now, around this wire is going to be create a magnetic field around the wire when the current is moving from one side to the other side of the wire. Okay? Now, something that is important here is also that if you see when the current is going like out from the I don't know, you're using the computer, yeah, from out of the computer, we can see right here that the motion of the magnetic field is counterclockwise, yeah. Think that this is 12, yeah, it's going in the opposite direction of the clock. Now, if the current is going like in of the computer or your iPad, going in the opposite direction, now the magnetic field it will go clockwise in the same direction of a clock. Yeah, that means this is the third point of this part right here that you need to remember. The direction of the magnetic field depends on the direction of the electric current. Okay, now points that we need to have here. First is electric current produce a magnetic field. This experiment made the connection between electricity and magnetic field that are related one with the other one. Third point is current carrying wire generate a magnetic field around the wire 360 degrees, and the direction of the magnetic field will depend on the direction of the electric current. Okay? This is the point that we need to have in your notebook. We have something else. Not only the poles of the corner of a magnet create a force on each other. Also, a magnetic field will extend or will apply a force on a moving charged object. What that mean? Let's see right here this diagram. Think that this is a magnet right here, and right here this is another magnet. Now we have this magnetic field that is going, north to south, that is going down. Yeah. Now if we have an electron, you can see here, negative E, that is moving in between these two magnets in this magnetic field, this is what will happen. This electron that is moving here is going to feel a force that is pushing this electron. Now, this is only going to happen when the electron or when the charge, can be an electron, can be something else, is moving. If the electron is not moving, or the object is not moving, it doesn't feel a force. Okay? It's not going, in the only way that this charge is going to feel a force that is like pushing is only when it's moving through the magnetic field. Okay? Now, the force on a moving charge is related to the magnetic magnitude of the charge, the velocity, that means how fast it's moving, the charge. Second is how big is this charge, and third is the strength of the magnetic field, that will depend on how strong are these magnets. Okay? Now, with the charge, the velocity, and the magnetic field, we can know how strong is going to be the force that is going to be applying, that is going to be trying to move this charge to one side or to the other side. Okay? Now, see it right here. With that, we can create an equation, and the equation right here will be this one. The force that is being applied to a charge, to a moving charge, is going to be equal to the magnitude of the charge, the velocity of the charge, and the magnetic field that is in between the magnets. Okay? Now, try to remember from the concepts that we have in the equation. For force, we are using F, and the unit is newtons. For charge, we are using Q, and the unit is coulombs, that is C. For velocity, we're using V, that is meters per second. Now for magnetic field, we're going to be using capital B, and the unit is going to be Tesla. Okay? Now, Nikola Tesla, that we have right here, the picture, this guy was a genius. One of the most amazing scientific in the history. Let's go with different points, see you can see a little bit about him. Nikola Tesla, he was an engineer, he was a scientist, and he designed the AC current or alternating current. Now, AC current or AC electric system, guys, is the electric system that we have in our house, in the school, between the buildings. Is the electric system that is in most of the world. Okay? Is the predominating electrical system used across the whole world right now. He also created the Tesla coil, that is really important, which is still used in radio technology. Okay? In his career, Tesla, he discovered, he designed, and he developed a lot of important inventions. Now, most of the things that he created, they were patented. The name of most of these inventions were taken by other people, but most of people know that he was who invented most of them. And these include dynamo, that are like batteries, and we know about the induction engine of motor. He also was a pioneer. That means he was one of the first ones that discovered the radar technology, X-rays technology, the remote control, and rotating magnetic field. Really important for most of the engines and that we have right now in almost everything. And the basic of AC machinery. That means Guys, we're talking about most of the things that we have in our house, in our school. The base of this technology, it was created by Nikola Tesla. Okay, now Tesla is most well known for his contribution in the AC electricity, AC current, and for the Tesla code. Okay, now like always, you're going to take notes on all the information from the video. Remember, most of the things that are in red. In your notebook, take the picture and upload the picture to Google Classroom. Have a good day.